Hello, here are the notes for Unit 1, Part 2 on absolute value. So we are going to start looking at what absolute value is. And it says absolute value represents the numerical value of a number without regard to its sign. The symbol for absolute value is two vertical bars, which you see here. Note that this is not an 11. Two vertical bars. An absolute value can represent the distance on a number line between a number and 0. Since distance is always positive, this is very important. Distance is always positive, so the absolute value is always positive or 0. The absolute value of a number is never, ever, ever negative. So when you think about distance, think about traveling. Let's say you travel to Maryland, to visit somebody, or maybe you're going to Ocean City, Maryland, and you're going south. That doesn't mean you're going negative miles since you're going down. Distance is always positive. So even though you're going south or going down, it's still going to be positive miles. So we have a couple of examples here. For the first example, we have the number -3 is 3 units away from 0, as shown on the number line at right. Therefore, the absolute value of -3 is 3. So here we have our absolute value of -3, and that's 3. So again, you're thinking about where -3 is located, and then how many spaces away from 0. So 1, that did not turn out the way I wanted it to. So 1, 2, 3. So -3 is 3 spaces away from 0. So that's why that's a 3. Anything in those bars either stays positive or turns positive. So the other example, we have absolute value of 5 is 5 units away from 0. So even though that 5 is positive, it is 1, 2, 3, 4, 5 spaces away. So the absolute value of 5 is 5. So we're going to look at some basics here. And we're just going to take the absolute value of what we got going on. So in 1A, we have absolute value of 54. So we want to think about, all right, how many spaces away is 54 from 0 on a number line? And that is going to be 54. So even though it's positive, it still stays positive. Part B, we have a couple things going on here. The first mistake we do not want to make is don't distribute. So a lot of times people see that negative sign out front and they're like, oh, I'm going to multiply and do that. No, you cannot do it. Those bars are not like a parentheses. So do not distribute. Instead, we are going to take our absolute value of -7 3/5. So we want to think about how many spaces away is -7 3/5 away from 0. Well, that's 7 3/5. Now this negative sign is out in front of the absolute value. That's going to get brought down and that's going to be put in front of our number. So our answer will be -7 3/5. And it's only negative because of that negative sign out in front. Letter C, we're going to do two things. We're going to take the absolute value of absolute value of 3, which is 3. So it's 3 spaces away from 0. We're going to bring it down our plus sign. And now we're going to do the absolute value of -5, which is 5. And then we're going to put them together and we will get +8. So you're taking care of the absolute value first and then doing the addition. In the last problem, letter D, we are going to be subtracting. So a lot of times people look at this and they want to make it a plus sign, but you do not do that. You are going to do exactly what it says. You're going to take 2.2 minus 5.13, which is -2.93. So you're going to do that subtraction. Now we're looking at that number and we want to see, okay, -2.93 from 0 will be +2.93 spaces away. So these first couple of examples, which we'll have on our quiz, are just finding the absolute value of a number. Okay, so we are going to bump it up and we're going to take a look at problem 2, 4, 5, and 9. So what's happening is when we go to solve absolute value equations, this may be new for you. We want to find out what can we plug in so that in this absolute value, we get the number 7 or -7. Because remember, absolute value, you could plug a negative number in or a positive number, and it will become positive. So there's always two answers every time. So what we're going to do first is we want to make sure that this absolute value part is isolated. It's by itself on that side of the equal sign. And since it is, we're going to get started. And we are just going to rewrite the problem, 2x plus 3 equals 7, just like you see it, but no absolute value bars. So we're rewriting the original problem, just like you see, removing the bars. So we will solve for that in a second. The other equation, we're going to take our 2x plus 3, but now it's equal to a -7. So the only thing that's changing is that 7 becomes negative. Again, bars for the absolute value are removed. So that can equal -7. That's all right. And we are going to solve for both. So if we take a look, we're going to start by subtracting 3 on both sides. So 2x now equals 4. And we'll finish by dividing by 2. To get our first answer is x equals 2. For the second one, we're going to start the same way. We're going to subtract 3. So we have 2x equals -10. And then we'll divide by 2 to get x equals -5. Now, it is a fantastic idea to check to make sure this is correct and use your calculator. So for example, I want to check my answer, x is 2. So I will take this part up here. I will take 2 times 2, because that's my x, plus 3. And 2 times 2 is 4. 4 plus 3 is 7. And absolute value of 7 is 7. So that works out. Perfect. So we check that one. Now let's check -5. So again, plugging it back in for x, 2 times -5 is -10. -10 plus 3 is -7. Absolute value of -7 is +7. So that's going to work out as well. So it's always a good idea to check your answers. And notice that they're different numbers. A lot of times people get one answer, they'll get 2 and they'll be like, oh, it's 2 and -2. That does not always happen. So you want to make sure you work it out fully. All right, let's move down to number 4. So again, first thing we want to make sure is that that absolute value is isolated. It's by itself, which it is. So we're going to set up our 3x equals 27. And I'm going to switch colors and do 3x equals -27. So again, it's the same process that we just did. Take it, split it into 2 parts. So we're going to solve by dividing by 3. So x equals 9. And again, if you plug it back in, you take that 9 and plug it back in, 3 times 9 is 27, and absolute value of 27 is 27. So that works out. Over here, we'll do the same thing. We'll divide by 3 to get x equals now -9. And if we plug that back in, 3 times -9 is -27. But because of the absolute value bars, you get +27. Okay, so let's take a look at problem 5. And again, same steps. We want to make sure that this part is isolated, the absolute value. Since it is, we'll get started by saying x minus 5 equals 2. And then we'll switch and do x minus 5 equals -2. So we're going to solve for both. So this is good practice of solving equations. We're going to add 5 to both sides to get x equals 7. If we plug 7 back in, 7 minus 5 is 2. Absolute value of 2 is 2. So that side works. Over here, we're going to add 5 and get x equals 3. And if we plug 3 back in, 3 minus 5 is -2, but absolute value of -2 is 2. So again, 2 answers, 2 equations, both of them work out. Last problem in the notes is number 9. So again, we want to make sure that that absolute value is by itself. So we're going to do x plus 2 equals 4. So we're going to set that part up. And now we're going to do x plus 2 equals -4. So we're going to solve for both. So we're going to minus 2 on both sides. So x equals 2. If we check, 2 plus 2 is 4. Absolute value of 4 is 4. That works out. Over here, we're going to subtract 2 from both sides. So x equals -6. We plug -6 back in. -6 plus 2 is -4. And -4, absolute value of that is 4. All right. So this will be it for today for the notes. And we will move on with the rest tomorrow.